Hey class, today we're going to learn about covalent bonding and we're going to start chapter 8. But before we can actually talk about covalent bonding, we're going to review a little bit of what we learned in chapter 7 because these two chapters kind of go hand in hand in the type of compounds that different elements can make. So in the last chapter, we talked about what are ionic compounds and then how are they formed, and we also talked about several characteristics of them. So an ionic compound is a neutral. Again, neutral just means that they have no charge. And it's composed of two things. We got cations, which we talked about were positively charged metal ions. And then we have anions, which are negatively charged nonmetals. These are held together by something we called ionic bonds. Now, typically, ionic compounds is going to be between a metal and a nonmetal. So an example of this was NaCl. We had a metal and a nonmetal. Or if we had MgCl2, we have a metal, again, and a nonmetal. We also talked about some properties of ionic compounds. We said most of them are going to be solids at room temperature, specifically crystalline or crystals. They have relatively high melting points. And whenever we melt or dissolve them in water, they can conduct electric current. These are also really stable. We've talked about that as well. Now, we're going to take this information and learn about a second type of bond that can form. So recall that ionic bonds formed whenever an atom gave up and another atom accepted electrons. In other words, there was a transfer of electrons. Somebody lost and somebody gained. But that's not always the case. Another way that atoms can combine is by sharing electrons. When they share electrons, they can actually still fulfill the octet rule and get 8 electrons, but instead of stealing them from somebody else, again, they are sharing between them. Anytime we have atoms that are held together by sharing electrons, we call this a covalent bond. And I'm just going to go ahead and star this because a lot of people lose this in their notes. Now, a covalent bond is a little bit different than an ionic bond. Whereas an ionic bond was between a metal and a nonmetal, covalent bonds are actually between two nonmetals or metalloids. One thing to note is they have no metals in a covalent compound, so no metals at all. If you see a metal, it cannot be a covalent compound. So some examples of these is O2, H2O, CO2, and N2O cannot be explained using ionic bonding. There are no metals within these things. And they also do not involve a transfer of electrons. These are going to be examples of things that share electrons, and these again are going to be covalent bonded together. We see all nonmetals here. Now, things that are covalently bonded together, like if we had an ionic bond, it made an ionic compound, but for a covalent bond, it can make something called a molecule. A molecule is a neutral group of atoms that are joined together, and they are joined together, again, by sharing electrons. Neutral, again, we're going to see no charge. A good example of this is oxygen gas. Oxygen gas is actually abbreviated O2. It consists of two oxygen atoms covalently bonded together. Whenever we have molecules, they can be made of atoms of the same element, like we saw with oxygen or O2. It's only made up of oxygen, and there are 7 elements that can bond to each other and form something that we call a diatomic molecule. Di, again, meaning 2, atoms, atomic. There are 7 elements that do this: hydrogen, nitrogen, oxygen, which is the one we talked about, and then we have our halogens: fluorine, chlorine, bromine, and iodine. If you actually look on the periodic table, hydrogen's over here, and then nitrogen, oxygen, and fluorine actually go over, and then chlorine, bromine, and iodine go down, so it kind of forms a 7 on the periodic table. Plus, little hydrogen over there. Now, we also have molecules that can be made up of different atoms. And molecules that are made up of different atoms, we actually call these a compound. Hence, compound's definition from first semester, two or more different atoms. And we call these things molecular compounds. So if you hear the word molecular compound or covalent, this is what we're talking about. Again, molecular compounds are held together by covalent bonds. So sometimes I use this interchangeably, molecular compound or covalent compound. They mean the same thing. A good example of this is water. Water, we have two nonmetals bonded together, and they're two different elements. So that's why this is going to be considered a molecular compound. No, all molecular compounds are going to be considered molecules, but not all molecules are molecular compounds. So what information does a molecular formula provide? Just like an ionic bond has a chemical formula, so does a molecular bond or a covalent bond. And essentially, they're going to tell you the exact same thing. They're going to tell you how many atoms of each element there are and what elements are provided. A good example of this, if we look back at H2O, the formula for water, H2O, if I look at this, this is going to tell me I have hydrogen and oxygen as part of its formula, and then my subscripts are going to tell me how many. So this 2 is going to tell me I have 2 hydrogen, and then if you don't see a subscript, it's considered 1. So here I have 1 oxygen. Another example of a molecular compound is butane. Butane has the formula of C4H10. This is going to tell me that I have 4 carbon and 10 hydrogen. One thing I want you to take note on is for a molecular compound, notice I have a 4 and a 10. This can actually be reduced. However, molecular compounds do not reduce their subscripts. So if it's ionic, we've always reduced it. If it's molecular, we cannot reduce. And that's because a molecular formula is different than an ionic formula or formulas for ionic bonds, is because the molecular formula reflects the actual number of atoms. Those subscripts are not reduced to the lowest whole number ratio. So if you see something like C6H12O6 and be like, oh, we can reduce this by dividing these all by 6, we don't actually do that for a molecular compound. We know it's molecular because these are all nonmetals. So again, in other words, it does not show, the other thing is that a molecular formula, while it does tell you how many of each element in the kind, it does not tell you anything about the molecular structure. It doesn't tell you who's bonded to who. It doesn't tell you what shape that structure takes. So we don't know the arrangement of those atoms within the space that they're located. There are diagrams that do show the arrangement, but again, a formula cannot. So here is a molecular formula. Again, we can only see the atoms and how many, but these other things will actually tell us our shape. Specifically, the one that we're going to work a lot with is called a structural formula. So the arrangement of atoms within a molecule is called a molecular structure. And so this is more than just a formula. This is an image or a depiction of how those atoms are bonded to each other. A molecular structure of carbon dioxide is going to show that there are 3 atoms in a row, and it's going to show that carbon is going to be in the middle and oxygen is actually going to be on either side. This also shows that this structure has them arranged in a linear fashion, and we're going to find out later on this takes on a linear shape. Oxygen and hydrogen, when it forms water, doesn't give us a linear shape, even though we have 2 hydrogen for 1 oxygen. You're going to notice oxygen's in the middle, but my hydrogen over here are not in a row. They are kindly on one side of the atom. And this does not give me a linear structure. This gives me something called a bent structure that we're going to learn here in future lessons. So again, the formula doesn't actually tell me what shape it's going to take. I have to look at the molecular structure when we draw them out. Another example of this is C2H6O, which is ethanol. This gets a lot more complicated. Again, the formula doesn't tell me anything, but if we look at the molecular structure or drawing, which we're going to learn to do in the future, this tells me that I have each carbon is bonded to 4 atoms, each hydrogen is bonded to 1 atom, and 1 oxygen is going to be bonded to 2 different atoms. So again, it tells me who is bonded to who. We're going to end off this section with how are molecular compounds different from ionic compounds. We did mention a lot of these differences at the very beginning of the lesson, but I am going to incorporate it here at the end just for us to be able to distinguish. So one comes down to something called a representative unit. For an ionic compound, we said that the representative unit was a formula unit. Remember, a formula unit is simplified, whereas molecular compounds are made up of molecules, and these are not simplified. We care about how many we actually have. In terms of the bond formation, ionic compounds are going to transfer, whereas molecular are going to share. The type of elements, ionic is typically between metallic, which are metals, and then non-metallic, which are non-metals. Whereas molecular compounds are going to be between non-metallic elements or non-metals. Sometimes we say metalloids in there because they can be thrown in, just no metals. The physical state ionic compounds are typically solids, whereas molecular compounds can be solids, liquids, or gases. And then for the melting point, this one says high and high, but I'm going to actually say these ones are typically higher. And then over here, because it says below 300 degrees Celsius, these are going to have lower melting points. In terms of solubility, ionic compounds tend to be really soluble, whereas molecular compounds can be, but they can also not be soluble at the same time. And last but not least, are they conductive? Ionic compounds are good conductors, but molecular compounds are very poor conductors, which means they don't really complete an electric circuit. Here is a good example of the representative unit. Again, representative units are going to come into play later on. For an ionic compound, we said that those representative units is a formula unit, whereas a molecule or molecular compound is going to be a molecule. And that's the end of today's lesson. If you have any questions, please let me know, and I hope you guys have a great day.